and it's about our custom lights. We have created it for a sun, but we may have torches or other light sources. So let me add a torch. Where is it? And let me add it somewhere here. So you can see that I have a torch here, and my stealth factor will think that, okay, my torch is disabled by default. Let me change it. Now it prints us 0.5, like we are not under the sun, and it's correct, but we don't check anything about this torch. So what we're gonna do? We're gonna open our, for example, a blueprint for a ground torch, and check. I have a point light. Okay. Now in BP darkness detection, we also on maybe on begin play. No, we have to open ground torch, and for every light source we have to add some collision. Let's add a sphere collision here. It's too small now, and let's increase it. This will be a sphere collision that will define whether we should start checking this light source. So as soon as player will enter this sphere, this light source will be checked if he touches player. So let's increase it much more, like in this radius. It's fine. Scroll down details of this for the sphere, and on overlap all dynamics select custom, ignore everything, and overlap pawn. So now let's add a tag to the sphere collision, and let's call it light source. Save, compile. Open our BP darkness detection component. Open begin play, and let's add a sequence node. Let's delete event tick. Here we're gonna get our character and get its capsule component. And here we're gonna bind an event begin overlap. Also, we're gonna bind event and overlap. Here on event, create a new event, copy it, and paste it here, and connect it to end overlap. Now select function and select create a matching function. It will create us a function that will be called every time that component begins overlapping. Let's call it on character did overlap. Begin overlap. On character begin overlap. Open begin play again, and do the same for end overlap. Select function, create a matching function. Compile and save. Now on character begin overlap, we're gonna check whether other component has a tag. And the tag is gonna be how we have called it, light source. And if it is, then we're gonna get other actor and get components by class. We're gonna get point light. If you are using not only point light, then you also should get other lights here. We're gonna talk only about point lights because the main reason of this tutorial is to show you a way how it is done. And we should let's promote it to a variable. At first, let's call it point lights, delete this setter, get points light here, and add every point light from this array to this array. So we're gonna add for each loop and add every point light to our array. Now let's open on character end overlap and check if other component has tag. Light source, add a branch by holding B button on the keyboard, connect it, and if it is, we're getting other actor, get components by class of type point light component. And again, for each of them, we're gonna remove them from points light array. We're gonna get points light and remove item and connect this element here. Compile and save. So now, every time that we have overlapped with some light, it will be added to a list of lights that should be checked. But also we have to set up this points light by default. So now let's on begin play, right after binding and events, let's get a character, get capsule component, and get overlapping components. For each of them, we have to check whether it has a tag. Light source. If true, then we're getting this component and getting an owner of this component. After this, we will receive an actor that has such component, and from this actor we're gonna get all components by class of type point light and set this to a points light. This is needed in a case if we are, for example, loaded in a game already spawned on a torch. So points light should be loaded to this place also. Now let's open a scan and delete our print. Here, right after validate grid positions, let's add a sequence by holding S keyboard button and clicking somewhere in an empty space. Connect everything and tracing sound goes into Zen 1. Right after that, we're gonna trace point light. Let's create a new function and call it trace point light. Compile and save. an input of this function is going to be a point light. Let's call it light of type point light component. Point light component. Here we're gonna do a line trace by channel. Also, as for a trace sun, we're gonna provide it with an array of points to trace. So let's add a new input and call it trace locations of type vector and an array of vectors. Here we're gonna do for each loop for these trace locations connected to line trace by channel. And now on sun we have traced from a character to a sun. Here we're gonna trace from a light to a trace location. So that's why an array element is gonna be an end location, and the start location is gonna be a world location of a light. Let's draw it for one frame. Also, let's open ground torch and select a point light. Let's select a sphere and make it not hidden in game. Let's select hidden in game, remove, make it false, and go somewhere here. Well, it looks like a very giant sphere, by the way. So here is my torch. And it doesn't light such a big location as my sphere collision has. So I'm gonna decrease its size. Maybe to something like this. Let's see how it will look like. And increase it a little bit now. Compile, save. And that's fine. So we will only check if character somewhere here. Okay, back to darkness detection. And now let's add this function to our scan function. Here on a then1 of a sequence, let's call trace point light. It should be done for every point light in an array. Let's get point lights first and do for each loop. For each of them, we're gonna call trace point light and provide an array element as a light. Trace locations is gonna be a correct positions of a function validate grid positions. Compile and save. Now you can see the trace is not going, but now it is. Well, let's open darkness detection back, and trace point light should return us a closest ray as a sun. So let's break out heat. Let's set draw debug type as none and check if it was a blocking heat. And even not. We should not check if it was a blocking hit or not. We should just check a location. Or we should check maybe a trace end. Let's draw debug sphere. Draw debug sphere because honestly I don't remember where trace end is located. Draw it for 0.5. Okay, I'm drawing debug sphere for, yes, correct. Trace end is not what we're looking for. So we have to use maybe location. Okay, yes, let's use a location. So now we have to check an end of a trace where it has ended, and we have to check its distance from a character. Let's get a character. Or maybe not. No, that's incorrect. We have to check if our line trace has reached its destination. We have to check whether a location is equal to a trace location. And tolerance will stay 0. So if our trace has reached its destination of a point that we have provided to it, or hit actor was equal to our character, then we are gonna count a distance from a location to a character world location. So let's get actor location from a character and plug this value into a distance and plug OR into a branch. As for a sun, let's create a local variable, call it local min ray distance of type float and make it a single value. Now for distance, we have to set a local min ray distance, get local ray min distance, get a minimum between this one and a distance vector, and plug it here. So if a trace reached destination, how it's done in sun we're checking. Okay, we have a trace position, by the way. We should not use line trace, but I have already done it like this. Well, on trace sun, if there was no blocking hit, then we're on the sun. Okay. So now On completed of for each loop, we will have a minimum distance from a player of array of our torch, for example. Let's add the return node and connect it to a completed of a for each loop. And we're gonna get our local min ray distance and return it. Min ray distance. Compile and save. Now in scan function, we have to promote this min ray distance from trace point light to some variable. But we have to know, we can check a few points light. So we have to not only promote it to some variable, we have to set a minimum between a current min ray distance and the new one min ray distance. Or not, no, this will not work, I'm sorry. So we'll have min ray distance and let's make it an array. Min ray distances of type float and let's make it an array. Here we will get min ray distances and add a new min ray distance here. But before a for each loop, we have to clear this array. We have to call clear right before for each loop. Now let's add a new sequence node, get an array, and array floats have a function called min of float array. We will get a minimum array distance from this array, and this value can be promoted to min array distance variable and connected to then1 of a sequence. Compile, save. Back to BPC stealth system. Now let's add, we're not gonna add a new sequence. It should be computed with a sun. So let's disconnect set current stealth factor here and disconnect subtraction or even delete it. Here we have darkness detection closest array distance for a sun divided by 250. Now let's get a min ray distance from a darkness detection. If it is 0, then it hit it right into the actor. So actor is staying near a light, or light is shining right on the actor. If it is more than 250, it also can be 250, but for point light, I think that 250 is too small value, so I'm gonna divide it by not 250, but maybe 100 and clamp it. Between 0 and 0.5. Now we have to get a maximum of these values. And right after that, we have to get a minimum of these values. Now to a max value, we have to add something like minimum multiplied by 0.3. And now from a current stealth factor, let's subtract this value and set it to current stealth factor. Now let's try to start a project We have 1 now, 0, 5. Mm-hmm. 0, 5, and torch started to shine on us, but nothing happened. Value didn't change. We still have a 0, 5 here. So looks like something here is not working correctly. Let me start a project again and navigate somewhere here. Let's add a breakpoint here and check what is the minimum ray distance. Minimum ray distance is 0. So torch hit it right onto a nectar. And here we're getting 0, dividing it. Oh, yes, we're dividing it by 100. Well, we don't have to do this like this. So we're getting the minimum. In this case, it's gonna be 0 if we are on light, and just subtract it. Nothing else is needed. Remove breakpoint. And the problem is that in darkness detection, our minimum ray distance by default is 0. Let's make it -1 by default. And here we're setting a minimum ray distance. We're gonna check whether point light is empty. Let's check if it is empty. And if it is, then we're setting a min ray distance back to -1, because we can have a case when there is no point light that we're checking. Now back to stealth system, and here we are checking, we're dividing min ray distance by 100. So let's do it like this. Let's check if it is equal to -1 and add a select node. So if it is not equal, on false, we're returning a clamp result. If it is equal, then we're returning 1. Or yes, 1 will be fine. So in this case, always a clamp for the sun will be in work. Now when I will navigate in the shadow, it's still not working. Why? That's strange. So if min ray distance is equal to -1, we're okay. I have forgot to connect this select here. Let's connect it, compile, save, and start it again. Now shadow is working correctly. Um, Well, looks like a trace point light returns us a 0 because it reached some destination. And what if I will move here? It still returns me 1. Well, we have a problem in trace point light. We have a problem here. Let's delete this and delete this, and let's just use a trace sun function. Let's just copy it. So we will trace from a character to a light location, trace point light. Let's just copy everything and paste it here. But instead, we gonna use not sun component, get forward vector. We gonna we gonna use to location as a world location of a light. Compile and save. And now let's debug it. Let's print here a mean distance. 0, 0, 0 means that we are, well, I don't know why it prints us 0. Trace point light, trace position, and draw for 1 frame. So it's sun trace. Okay. It hits some point here. Well, but it should not. My traces goes through a door. Or not. No, they don't go through a door. But the problem is that my grid is a little bit too big for a point light. So for a point light, we're not gonna trace an array of locations. We're just gonna trace from an actor location. So let's remove trace locations input. Let's get a character and get actor location of a character, and it will be from. Compile, save. And we will return at the end. We'll count distance to location. Compile and save. And disconnect trace point light for on scan results. Well, so let's test it now, what it will print us. And we don't have to check a distance, by the way, for a point light. We have to open trace point light, and we don't need to count a local mean ray distance from some minimums. So let's delete it. Let's delete this local variable. And we should know whether it was a hit or no, whether a light has reached a player or not. So output will be hit of type boolean, and it's gonna be single, and not min ray distance, but distance from source. So if it was a blocking hit, we're returning this with hit true and a distance as a parameter. And if false, we are returning the same, but with hit disabled. Compile and save. Now back to scan function, and here after trace point lights, we're gonna delete min ray distances array, delete it from here also. No, we need min ray distances array. I'm sorry. If it was a hit, then we are adding this distance from source to an array. Right after that, we are looking for a minimum distance. And promoting it to a variable. Compile and save. And now let's print it. Print this minimum ray distance, not here, but before a branch. And it should print us a distance to our torch. Now it prints only sun, so distance to a torch is 0. What? Okay, I don't understand, by the way. Well, we should check whether it not only blocking hit, whether we have hit an actor in a trace point light. We should check also if hit actor was a character. Well, the way to implement this function in correct way is to trace position from a character or from a light to a character actor location, and if there was no blocking hit, if nothing blocked our trace, so if false, we're returning this. If true, we're returning this. And the distance is not going to be a distance of a hit. It's going to be a distance from a light source to an actor. So let's get a light component. Okay, we already have a world location of light component and actor location. Let's count the distance between them, calling distance. And this is going to be an output of a top result with hit true. Compile and save. Next, in a scan function, we still have an array, still tracing, and so on, checking if it was a hit, and adding it to an array of min ray distances. Now let's check our prints. Now torch started to be checked. Now I'm entering, and a distance is 0 now because I'm not around near a light source, and the closer I get, the bigger it comes. So I think that for point light, distance of 900 will be a maximum. So let's open a darkness stealth system, and here we're checking if min ray distance is equal to -1 and dividing it by 100. Here we are checking how close our character to a light source. So if it is close to 0, then we should subtract a bigger value. So we're dividing our value by 100. We should not do it. We should subtract this value from 800, 900, as I told, for a point light. And divide it by 900 back. So we will get something between 0 and 1. Let's clamp it between 0 and 0.5. And let's check it. So now my stealth factor is 0.5. And now it is bigger. Okay, it is increased in opposite way. So let's add minus and subtract this value from 1 and plug it into clamp. So value is still increasing. Okay, yes, correct. So it is decreasing when I'm far and when I'm getting closer. It is increased. But on such distance, it is already on 500 distance, it's not working. Let's check. If I have 500, I'm subtracting it from 900. We don't have to do it. And we didn't have to do it. That was incorrect, I think. Well, I think that things that we're doing here for sun and for a min ray is incorrect by default. So I'm gonna delete this for now. And we should not clamp between 0 and 0.5. We should clamp between 0 and 1. So here we're getting min ray distance, subtracting it from 900 and dividing this value on 900 as previously. And we will receive a distance from a sun in 0 to 1 range. 0 will mean that we're very close, and 1 will mean that we are very far. So what do we have to do? We have to find a minimum from them. As previously, we have to find a minimum from these values. It will return us some value between 0 and 1. 1 means that we are too far, and now let's but for sun, well, minimum will mean for sun 0 will mean that we're on sun. For a distance, 0 will mean that we're close to a torch. Okay, next we have to multiply this mean distance by 0.5, for example, and this is a value that we're gonna subtract. Also here where I have checked if min ray distance is equal to -1. Let's make a select again, And if it is equal to -1, let's move select here and plug it here. If false, we're returning a clamp result. If true, we're returning something big so that sun will always be selected. Now it should work. It works in more correct way. So now you can see that I'm sorry, I forgot that value should be less value means that we're hidden much more. So, well, now let's open darkness detection and scan function. And here, let's remove a print. And we have a branch that's checking if point light is empty. And if it is, we're setting mean ray distance to -1. We should also check if mean ray distances array is not empty. So let's get a mean ray distances. Check if it is empty. Add or condition. And plug this into a branch. So we will set mean ray distance to -1 if points light is empty or minimum ray distances is empty. Now back to stealth system to calculate current stealth factor, and this is how calculating should look like. We're getting mean ray distance and just dividing it by 900, clamping it and doing everything as previously. Now let's start the project and we can see, okay, 0.5 here, I'm in the dark area, and now I'm coming closer to a torch. My stealth factor is 1, that means almost 1, that means I'm very visible. And now I'm going far from it, and now my stealth factor is 0.5. If I will sit down, I will have stealth factor of 0.44. Here in this angle, I have 0.4 stealth factor. So you should add such logic, not a logic, you should add such a sphere collision for every light on your scenes that you want to affect, and you can tweak different values and add different logic here, because currently it may be not perfect, it's made on the go.